What if I told you that the entire world of AI is powered not by the infinite numbers you know, but by a tiny, almost ridiculously small set of them? It sounds kind of impossible, right? Well, today we are going to pull back the curtain on the strange and powerful number system that truly makes AI tick. And to do that, we're going to have to rethink a few things we all learned back in school. So let's start with a word you probably remember: vectors. Now, I want you to just, for a moment, erase that image of a simple arrow flying through space. In the world of AI, a vector is more like a digital fingerprint. Think of it as a neat little package of related data points. Like a patient's vitals, where each number tells one part of a much bigger story. And this brings us right to the heart of the mystery. How on earth can this little handful of numbers, just 5 of them, be more powerful for AI than the entire endless ocean of integers that we use for, well, pretty much everything else? It seems totally counterintuitive, but the answer is exactly what makes modern AI work. Okay, so what exactly makes a number system well-behaved enough for AI? To figure that out, let's take a closer look at these powerful data vectors. For a data scientist, a vector is just a really smart way to group related information. It could be all the pixel values in a photograph, or a stream of stock market data, or, like we saw, a patient's vital signs. The point is, it's all about organizing complex information into one tidy, manageable package. Right, but here's the catch. You can't just use any old numbers to build these vectors. Nope, they have to belong to a very exclusive club, one with a super strict rulebook. And in the world of mathematics, this club is called a field. So, what does it take to get on the list? The rules for getting into the field club are mostly common sense, stuff we already know. You need a 0 for starters. Adding or multiplying any 2 members can't get you a result that's outside the club. And every number needs an opposite, right? Like 5 and -5. But here it is, the game changer. The bouncer at the door is this last rule. Every member, except for 0, has to have a multiplicative inverse. That's just a fancy way of saying it needs a partner, a buddy, that it can multiply with to get exactly 1. This rule is what makes division possible, and for AI, division is absolutely non-negotiable. Okay, so with those rules firmly in place, let's see if our old friends, the integers, can make it past that bouncer. I mean, they seem like a shoo-in, don't they? We use them all the time for everything. But can they actually pass the Field Club's entry exam? Let's find out.
Well, they just breeze right through the addition rules. Is there a 0? Yep, check. Add 2 integers, you get another integer. Check. And for every integer, like 5, its opposite, -5, is right there in the set. So far, so good.
But now for the big one, the make or break test. Let's just pick an integer. How about 2? Is there another integer out there somewhere that we can multiply it by to get 1? Well, the answer is 1/2. But wait a minute, 1/2 is a fraction. It's not in the set of integers. And they fail. The bouncer just shakes his head and says, sorry, you're not on the list. The infinite set of integers is officially denied entry into the field club. And look, this isn't just some abstract math game. As Dr. Arland points out in the source material, this is a real problem. Integers are so simple and so easy to work with, which makes it a huge letdown that they're missing this one critical feature. So, just when it seems like our search for the perfect number system is doomed, an unlikely hero steps out of the shadows, a tiny little set of integers that plays by a completely different set of rules. So, say hello to the integers modulo 5. Now, this system only contains the numbers 0, 1, 2, 3, and 4. That is it. Everything here works based on remainders. The easiest way to think about it is like a 5-hour clock. If you have 3 and you add 3 more, you get 6, right? But on this clock, you just wrap around past 4 and you land on 1. So, this is the moment of truth. Can this little system of clock math actually do what the entire infinite set of integers couldn't? Does every number in here have a multiplicative buddy inside this tiny set? Just take a look at the multiplication table for modulo 5. The secret is hiding right there in plain sight. Do you see it? Notice how the number 1 pops up in every single row and every single column? That, right there, is our golden ticket. And this is where the magic happens. Every single non-zero number has found its buddy. The inverse of 1 is just 1. The inverse of 2 is 3, because 2 times 3 is 6, and the remainder of 6 divided by 5 is 1. And get this, the inverse of 4 is itself, because 4 times 4 is 16, which also has a remainder of 1. Everybody has a partner. And there you have it. This tiny, unassuming system passes with flying colors. Every non-zero member has its inverse, all tucked neatly inside the set. Welcome to the Field Club Modulo 5. So what's the big takeaway from all this? Well, it's that when it comes to the deep mathematics of AI, structure beats size. Every single time. A small, finite, but well-structured system can be infinitely more powerful than, well, an infinite one. We've seen that it works for the number 5. And that gives AI the solid mathematical ground it needs to actually function, to learn, and to solve problems. But, of course, this leads to one final and pretty fascinating question. Was 5 just a lucky number? Can this amazing little trick work with any number? Is the set of integers modulo 4 or modulo 6? Is modulo n always a field? Well, the answer to that, it turns out, is a bit more complex. And that's a puzzle for another time. Thanks for joining.